This module shifts from building the AMS to proving it works. You'll see how internal audits, management review, corrective actions, and certification readiness turn implementation evidence into confidence for ISO IEC 1421 Stage 1 and Stage 2 assessments. So far, we've built the aims from the ground up: purpose, scope, inventory, risk, and accountability. We then translated requirements into governed architecture, controls, monitoring, and evidence. The next step is readiness, using internal audit, management review, and certification preparation to show the system is implemented, operating, and ready for the capstone. Audit readiness starts long before the certification audit. The goal is not to assemble policies at the end, but to make conformity visible in daily work. Auditors will ask whether requirements have been translated into AI design choices, lifecycle controls, responsibilities, monitoring, and decisions. Then they look for evidence that those controls operated over time. Risk records, architecture decisions, incident logs, metrics, reviews, and improvement actions need to connect. A mature AIMS can trace a requirement through implementation, operation, review, and continual improvement. Internal audit is the organization's rehearsal before certification, but it is more than a checklist. It tests whether the AIMS is defined, implemented, maintained, and working. Strong audits are independent, risk-based, and evidence-driven. For AI, that evidence must cover both governance and technical controls, including data, models, pipelines, security, monitoring, and human oversight, so issues can be found and corrected early. Effective internal audit planning answers 3 questions: what is in scope, what requirements apply, and what outcome the audit should achieve. For an AI management system, scope should connect to the AIMS scope, AI inventory, organizational boundaries, processes, locations, and supporting data flows. Criteria come from ISO IEC 4221, annex controls, internal policies, risk treatments, procedures, and legal duties. Objectives make the audit actionable: verify implementation, test effectiveness, confirm evidence, or validate corrective actions. Give extra attention to high-risk AI systems, critical datasets, deployment pipelines, and incident handling. An AIMS audit program should be a planned cycle, not a one-time inspection. It needs reasonable coverage across systems, models, datasets, vendors, and environments. Sampling starts with risk. Higher impact use cases, recent changes, incidents, weak controls, or critical vendors deserve more attention. The sample should also represent the life cycle from design and development through validation, deployment, monitoring, change, and retirement. For each item selected, auditors connect governance records to operational evidence, such as approvals, test results, logs, alerts, evaluations, and incident files. Once scope and criteria are set, map each requirement to the roles that own it: governance, architecture, security, data science, operations, legal, product, and the business. Prepare questions that test real understanding, not memorized policy language. Evidence requests should be specific: what artifact, which system, what time period, and which control it supports. Then compare interviews against operational proof, such as tickets, model cards, approvals, dashboards, logs, and risk decisions. When these sources agree, confidence rises. When they conflict, you have a lead for deeper testing. An internal audit tests 2 things: whether the control is well designed and whether it actually operated. Design testing asks whether the control fits the AI risk, the system architecture, and the ISO IEC 1421 requirement. Operation testing asks whether it was performed, recorded, reviewed, and escalated when needed. The strongest evidence connects the full chain: risk assessment, selected control, implementation record, monitoring result, and improvement action. For AI, look for repeatable proof: model evaluations, data quality checks, human oversight, security monitoring, and incident handling that actually occurred. Audit reporting turns evidence into action. Start by classifying each result: conformity, observation, improvement opportunity, minor nonconformity, or major nonconformity. For any nonconformity, make the logic traceable. Name the requirement, cite the evidence sampled, explain the gap, and state the risk or impact. Then assign the right severity, owner, and follow-up deadline. Avoid vague phrases like process not adequate. Use verifiable facts, such as missing approvals, incomplete risk treatment records, or inconsistent model monitoring. A strong report shows that issues are understood and controlled. Corrective action starts with containment, but it cannot stop there. Containment protects users and operations from the immediate risk. Next, the team asks why the failure happened, looking beyond symptoms into process design, role clarity, tools, training, architecture, and governance. The corrective action plan turns that diagnosis into accountable work. An owner, deadline, resources, evidence, and a way to test effectiveness. For AI controls, closure means behavior actually improves. Monitoring thresholds are sharper, validation gates catch issues earlier, and approval workflows make the right decisions repeatable. Management review is where AI governance becomes executive accountability. Operational evidence, including audit results, incidents, metrics, and control performance, is brought together to judge whether the aims is still suitable, adequate, and effective. Leaders test that evidence against strategic objectives and the organization's AI risk appetite. Then they decide whether to keep controls as they are, strengthen them, change priorities, or allocate resources. The key output is not the meeting itself. It is documented decisions, assigned actions, and approved improvement priorities that drive the next AIM cycle. A management review is only as useful as the evidence brought into the room. Start with AIM's objectives, performance metrics, current AI risk status, and any changes in scope, context, or obligations. Add audit results, nonconformities, corrective actions, incidents, complaints, and stakeholder feedback. Then test whether controls are working across data, models, monitoring, security, human oversight, and suppliers. Finally, convert the evidence into decisions about resources, training, tooling, policy changes, or architecture changes. The goal is not reporting. It is informed direction and accountability. The value of management review comes from turning discussion into decisions people can execute. The output should clearly state what leadership approved: aims improvements, control changes, risk treatment updates, policy revisions, or resources. That may mean funding LLM monitoring, assigning a new control owner, remediating an architecture weakness, training teams, or taking supplier action. Each decision record should capture who decided, what evidence they used, the deadline, and how progress will be tracked. Route those outputs directly into action plans, roadmaps, risk registers, and audit follow-up, so closure is visible. Certification audits test more than documentation. Stage 1 asks, are you ready? Auditors check scope, context, risk processes, objectives, and whether required information exists and is coherent. Stage 2 asks, does it work? Auditors interview people, sample records, follow processes, and look for controls operating effectively. The biggest preparation mistake is treating evidence as a last-minute collection exercise. Build evidence packs, brief staff on their roles, rehearse control walkthroughs, confirm audit logistics, and be ready to explain corrective actions. Readiness is disciplined proof, not polished storytelling. The final step is proving that your aims works in practice. Internal audits test requirements, controls, evidence, and process discipline. Management review brings leadership into decisions about performance, risk, incidents, resources, and improvement. Certification preparation then turns that evidence into a credible demonstration. In Module 6, you'll apply the full path through a capstone implementation case.